students, today we're going to learn about conic sections. Ellipses! The first problem will be... Now I write on the
board! That's where we stop. Because I really don't know what the first problem is. Alright, this is fun. Third installment of conic sections.
Woohoo!
The ellipse. Thank you, that was great. I wish more people.
Woohoo!
Sounds like it's a roller coaster. But like not the first one. The first one would be like, ah! And the last one, like when you're about to pull it, it's like, woohoo! Like for the little baby who's crying. One time when I was in 8th grade, in King's Dominion, back in Pennsylvania, I put on the thing, you know, for the upside down roller coaster. And like, you know, you put it on, it's safe. You go up and down, and everything, 6 loops. It was big at the time. And then it was like, you know, it stops, and then it goes it pulls back into the station, whatever, at the end. And I was like, you know, I can slide my head through these things.
Oh, no.
So I was like, and I like slide out and like slid my shoulders through, and I was basically sitting outside the thing from behind. And then like, I get out and I'm like, thanks! And they like turn white. They're like, funny memory.
It's a one time.
Here we go. Remember the circle?
Yeah, we do.
Here we go. It starts with the circle concept. All right, we have an x squared and a y squared. For the ellipse, x squared and y squared again. Based on what we know about the circle with the vertex, what's the vertex of this particular ellipse so far?
0,
0, 0, good. All right. And the ellipse, one big difference is that it'll equal 1. Okay, so before the circle had a radius squared here, now this equals 1. And underneath each of these are certain numbers that we're going to use. Okay, the certain numbers we'll use now, let's call this one 64. And let's call this one 49.
There's a reason why they're squared.
There is a reason why they're squared, correct. Okay, so let's start this particular ellipse. Ellipse is basically an oval shape. Okay, so using our astronomy reference before, we're going to talk about like elliptical orbits a little later. Let's do this. Graph coming. The center is 0, 0, so draw that and draw a point at 0, 0, please. And here's how it works. We look at the value under x. Okay? Usually we call this a squared. Alright, the value under x is a squared.
8.
And so what is the value of a?
8.
8. Okay, the value of a is 8. And a is the value that we move left and right from the vertex. Because it's x. So since a squared is under x, we're going to move 8 over here. What's this point?
8.
8, 0. Good. 8, 0. Clean it up, make it better. 8, 0. What's this point over here?
Negative 8.
Negative 8, 0. Okay. And this value underneath y squared is called b squared.
Or B.
So b squared is 49.
So B is 7.
So b is 7. And where do you think we go with 7?
Up and down.
Up and down. So 0, 7, and 0, negative 7. And this is our ellipse. Notice it's not a circle, it's an oval. It's an oval.
Yes.
So let's just draw it to the best of your ability. We're not looking for Monet here. Okay.
Do we ugly it close?
Right. So that's the ellipse. Any questions so far? Okay. Now the only difference in the next couple problems we'll do is that we'll start at a different point. But from that particular vertex, then we would go 8 left and right, or 7 up and down. All right, so that's the idea. So this is the basis for our ellipse. Now, an ellipse has a focus point, just like the parabola, except it's not one focus point, it's 2 And that's called foci. Yeah, foci for plural. So F-O-C-I-I means two focuses. Yeah. It sounds like Japanese, what's it called? Noki?
Yeah.
Yeah.
Gnocchi.
Yeah, so we're going to solve for these, for the two focus points. Alright, so we're talking about elliptical orbits. If a planet or a comet or an asteroid or something has an elliptical orbit, it's actually not orbiting a center point per se. It's orbiting two imaginary points in gravity. Two imaginary points in space. Right? So these focal points are what we're going to solve for. Here's how it works. Equation for the foci of an ellipse goes as following. Okay. It's kind of like backwards Pythagorean. That's how I look at it too.
Yeah.
And with the knowledge that -c. With the knowledge that the foci will be at a distance of c away from the center. It would be positive c, good, thank you. This would be positive c away from the center, negative c away from the center, and the foci will always be on what's called the major axis. Okay, so major axis. Major axis is the long one. Is the long line, I'll tell you, from x to x. Major axis in this case is 16. Major axis has a value of 16. So if I ask you, what is the major axis? You would say, okay, it's the longest, like a kind of diameter, if you will. The longest diameter. In this case, this one is stretched because the value under A is bigger. And so it's 16. What do you think the minor axis will be?
14.
14, right on. 14. So minor axis equals 14. Okay?
Will the major always be the x-axis?
No. An ellipse can be long like this, and that's what we're going to do next. And so the major axis will be the long one. It's the longer one, the major axis. Okay, so let's solve for c. What's a squared?
64.
64
Minus 49.
minus 49.
15.
15.
Root both sides.
So if c squared equals 15, what's the value of c?
Root 15.
Root 15. So c equals square root of 15. Now, what is the square root of 15 approximately?
3.872.
Quick, 3.8. A little under 4, 3.8. Good. So that's the distance that we're going to go from the center. And since foci always go on major axis, all right, if you think of an orbit, it makes sense that the orbit would be around like the long side of the ellipse. All right? So at this point here is negative root 15, 0. Here it comes.
So it's always on the major axis?
Always, foci are always on major axis.
So it's 3.8 away from the center.
The center, yeah. So in our case, let's just write root 15. So root 15 away from the center and root 15 away from the center. So those are the foci, and that is it. That is it.
What is the foci measuring?
Okay, foci are imaginary points.
But what do they tell you about them?
What they tell you is like, what are the points of an ellipse in which the have you heard of like the concept of center of gravity?
Yes.
Yeah.
All right, center of gravity. It's like they are the focal points of the ellipse. They're the center of gravity of an ellipse. So if something in space had this orbit, particular orbit, naturally much bigger, right?
Yeah.
But like the relationship, it was 8 to 7, let's say.
Yeah.
Then this thing that's orbiting would actually be orbiting a fixed point in space that is like root 15 away from the middle of this ellipse. It's like around what points does the orbit occur? These two. All right, they kind of carry the ellipse, if you will. All right, two more.
Does
Two.
not.
2 more.
What if it's 2x squared?
It's always going to be just x squared,
Oh, okay.
just y squared. If not, then you'd have to you divide both sides, let's say, by something, and make it so that it's 1x squared. 1x squared with a vertex, but then the number on the bottom is crucial.
Okay.
All right, let's do this. Finally, yes. It's great that I don't take it personally. We're like, boo algebra. People will be like, hey! Why do I stand like that, you know?
It just comes naturally to you.
It does. Write it bigger. I talk to myself.
Do you answer yourself?
I heard you.
Are we back to circle?
No. The basis is kind of the same. And I'm going to write it in a piece by piece. What's the vertex of this particular ellipse?
3, 2.
3, 2. 3, 2, correct. Good. Keep that in mind. Yeah.
Is that the same thing?
Center, yeah, center. I meant to say center.
What's in 19 days? Does it all? Yeah.
Ellipse goes.
Okay. So, let's start the graph. So 3, 2 is the center. I'm going to draw my graph like this, and hopefully you'll understand why. There it is. So please draw a center point of 3, 2.
We do that too.
Yeah, please.
No, I need the graph like that.
Yeah, it's a good idea. So it gives us room to work with. 3, 2. Looks like I need a little space on y actually. We need a little space on y because we're going down 5. I'm fixing. Fixing y. Fixing y. I saw it. Better to fix something as soon as you see it, right?
Better not to make the mistake.
Then let it fester. Fester me fester. Okay. So there's 3, 2. Someone tell me what to do.
You take x.
Okay, so let's talk about the a squared and b squared. In this case, a squared is going. Yeah, I know why you're saying it's 3. We're going to build onto that what we just did. A squared is always the bigger one. A squared is always the bigger one.
Oh.
Yeah. So what's a squared?
3.
9.
25.
Oh.
25.
Oh.
Okay.
What's a squared?
Whoa, wait.
A squared is 25. A squared is the bigger one.
Oh.
In other words,
Oh, so you can subtract it without negative?
right on. So remember the equation for the foci, it was a squared minus b squared. So that's why a squared needs to be bigger. So a squared is the bigger one. So here comes a squared and b squared is over here. Okay. So we have major axis and minor axis. Let's do it. How far up and down are we going? How far left and right are we going? Anyone? Yes?
I think we're gonna go left and right, 3.
How do we know that we're going to go left and right 3? You're right.
The whatever's under x.
That's the number under x.
Oh.
And x is a left-right thing. So we're going to go left and right 3. Question.
So the a and b are the major and minor axis.
Good.
And x and y is the up and down or across.
Yes. Yes. So let's do it. Okay, so we're going to go left and right 3. So if we go left and right 3, what's this point?
6, 2.
6, 2. Looks good. 1, 2, 3. 6, 2. Let's open the plastic, please. Okay, and then what's this point? 0, 2. Yeah. Okay. 6, 2, and 0, 2. Now how far up and down are we going?
5.
5. What's
From the original.
5 from the center point, exactly. Can you tell us what that point is? Either one, up or down?
Going up.
Going up?
7.
3, 7.
3, 7.
Yeah, 3, 7.
Good. And going down?
-7. Or 3, -7.
Nope. Not 3, -7. Try again.
3, 5.
3 negative 5.
3, -3.
Three.
Because we subtract 5 from the y value. We subtract 5 from 2, that's -3. So 3, -3 down here.
Yeah.
Okay, we've just drawn our ellipse now. Notice it's a longy. Alright, it's a longy now. Good.
So now the major axis goes up and down.
So, yeah, the major axis, hopefully you'll realize, well, what's the major axis now?
It's gonna be
How much?
10.
10.
10. Good. Major axis equals 10. So here's what's interesting. The book, they say the major axis equals 2a. So I leave that to you. It's up to you. If you want to remember major axis equals 2a, be my guest, it's totally cool. If you want to remember major axis is this distance without a formula, you can do that too.
2a is
2a.
And then
What's a? What's a?
A is 5.
So 2 times 5 is?
10.
And we just said the major axis is 10.
and then
So
minor
2a.
axis is gonna be 6.
Yes. And
So
so
then
what do
you
you think the formula for
2b.
minor axis is? 2b. 2b.
Or not to be.
To be or not to be would not be the minor axis. That's right. Minor axis equals 6 equals 2b. Okay, good. So minor axis is this way. 6. Okay, so that's it. One more thing to do. Foci. What are the foci? First of all, where will they be? Will they be on the minor axis or on the major?
Major.
On the major. It'll be on the major, so it'll be somewhere here and here. Alright, if it's going to be somewhere here and here, we could even start off our points. What do we know about this point? Do we know it's x or y already?
Yeah, we know it's y. It's x.
We know it's x. So what is its x? 3, because we started at the center and we're moving up and down. So this is 3. And the other side, let's say minus.
It's gonna be 3 something.
So it'll be 3 something also. Okay, let's do the equation. C squared equals what?
A squared minus B squared.
A squared minus B squared, lovely. Which is what minus what?
25 minus
25 minus 9? What are you saying? The answer?
16.
Yeah, equals 16. So what's C?
4.
4. So the length of the focus, each focus, is 4 away from the center.
Okay.
Let's
so
do
if you're
it.
at
Oh, so it's
3,
up
2, you're
4.
gonna be
Up 4, down 4
so
from the
3,
center.
6.
Let's do it. What'd you say? 3, 6.
6.
Sounds great.
And then 4 down is gonna be
3, 6. Any question about this first focus is 3, 6 because we started at 3, 2 and went up 4, 3, 6.
So then it's gonna be 3, -2.
3, -2 is right. Okay. That's it. That's the ellipse. Questions?
These aren't solvable on calculators.
To solve these on a calculator, you would have to isolate y. Okay? Get y by itself,
Oh my God.
meaning bring this over to the other side, bring it to 1, FOIL this out, okay? And
Way too much work.
and then take the 25 over, yeah. And you would get the top part, basically. You would get the top, because this is not a function. All right, one more, friends. One more. Okay. I feel like you're getting it. Are you getting it?
Yeah.
I feel like you're good, man.
I
Good.
love math.
Yeah. I feel like you're getting it. So let's play a little experiment with this last one. The experiment is, I'm not going to give any answers. You're going to tell me everything. This will be fun.
Well, that's not fun for the viewers at home.
Oh no, that's the most fun for them. What did you say, viewers?
Yeah!
Oh,
We're not viewing.
Yeah, we are. We're the crowd.
Don't you wish you could be here? Oh! Oh! They know they want to. Yeah. Like this. Like this. Come on, sing it up.
If you want to roll like this,
Like this. Like this. Like this. Like this.
Good.
give it up for Mr. Adidas.
I like
Robert.
I have a question. Could we do it the opposite way?
No.
What opposite way?
So like if they give us a graph and we find
Yeah. Exactly. If they give you a graph, look at the major axis.
Right.
Let's say the major axis was 8. Good question. Major axis is 8. So we went 4 up and down, correct?
Right.
So what is the value of A?
4.
4. So what's A squared?
16.
So it would be 16 on the bottom of the
Alright.
Y one. This is okay. So it's good. You can totally work backwards. All right. What should I do first? Let's take turns here. Go ahead.
Find the center.
Find the center. What would it be?
2, 0.
2, 0. Then what should I do with it?
Graph it.
Graph it. Good. Good stuff. 2, 0.
Graph.
There's 2, 0. And we graph the center. Okay, volunteers to do the next step. Yes.
So now you're gonna find A and B.
Let's find A and B. So
So A is gonna be A is gonna be 4.
A is going to be 4. What should we do with this 4? What should we do with that number 4?
Now you're gonna go up and down.
Up and down what?
4.
So where would that lead me? Us.
It's gonna lead you to 4.
2, 4.
Is it left and right?
No.
Why is it not left and right? Can you explain why it's not left and
It's
right?
not left or right because it's going Y.
Because it's under Y.
Right, okay.
Very nice. Well played. Yeah, I watched the door on the exit. Okay, so 2, 4, and then the bottom
2,
point
negative
is 2, negative 4. All right, next step, someone else. Please.
Wait, what was the fourth one? Oh, the
four,
A.
The A, yeah. Next step, anyone. Please.
B.
B is, you find B and it's 3.
B is 3, so what do we do with that?
You go right 3 and left 3.
Right 3 and left 3, why?
Because it's under the x-axis.
Under the x-axis. What point would we end up? This was 2, 0.
5, 0.
5, 0.
And then negative 1, 0.
And what?
Negative 1, 0.
Negative 1, 0. Next step?
Draw.
Draw. Draw. Draw. They don't make them like that anymore. To me, you guys, I want you to think about just for a second how cool it is that like 20 minutes ago, if I asked you to, hey, graph this, you'd be like,
Cricket.
yeah, cricket. Yeah.
Wait, so from the 3, when we went to the left?
From the
that-
3, we went to the left.
Yeah,
Yes.
so 1, 2, 3. Alright,
1, 2, 3. Yeah. So this one's the longy, good. And a few more things and we're done. What's next?
Major.
Major axis, minor axis, love it.
The major is 8.
Major ax. I've done that every time. You realize that? Equals 8.
Minus.
Minor axis is 6. Great.
Now we gotta find the foci. Whatever you wanna call it.
Yeah, with the sharp C. Foci. So, if you want to find the foci, what will they be? How would we do
16
it?
minus 9.
So what's the formula, please?
C squared equals
A
A
squared.
squared minus B squared.
Very good.
I don't remember that.
Bigger.
Bigger and cleaner, right? Okay, so you said 16 minus 9?
Yeah.
5. 6. 7.
7. Right. Bronze medal. C squared equals 7.
C
So
equals root 7.
C equals root 7. You know what's interesting?
What?
C technically equals plus or minus root 7, which is exactly where we're going. Up and down root 7. Right. So C equals plus or minus root 7.
Plus or minus.
Right.
What does that mean to our graph?
What does that mean to our graph? That's exactly the right question. So, foci. So far, you're playing the game
So
well.
it's gonna be 2 plus or minus root 7.
So what are the points?
Is that it? Just 2?
Root 7. Oh.
7?
2 root 7.
2 plus
Two-
root 7.
2 plus or
2
minus.
root 7, right?
Yeah, and then. Okay.
2 root 7.
And then
Negative 2.
Negative 7.
Try again. I know what you're
Negative.
saying.
2 negative 2. No.
You're almost there. You're almost there.
Root 7 negative 2. No. 2
X comma Y.
2
Negative
negative root 7.
Say it again.
2 negative root 7.
2 negative root 7. Good. You just go a distance of root 7 the other way. So if we went root 7 down, that means it affects the y. And it affects the y, we're going down from the 0 point to negative root 7. So this point here, 2 negative root 7.
Yeah.
Good. Good. How was that? Ellipse?
That was
So
about
rank it so far. We've done parabola, circle, and ellipse. Which one's the easiest?
Circle.
Circle. Someone say ellipse.
I think circle.
Ellipse or circle?
Okay, ellipse, ellipse, circle, and then parabola.
Third.
yeah.
Right.
That was wrong.
The next one's the hyperbola,
Oh
and I
man.
think that's the hardest one. So
Yeah.
you guys are ready for the hardest one. That's why they do it
That's
last
a
two.
funny name.
Hyperbola.
Yeah.
You're
Sounds
gonna
like
get a lot of
weird type
angry
of
math
color.
letters.
Hold up.
A lot of angry math letters.
Um,
Yes, question.
let's say it's equal to like 9. Okay.
What's 9?
Instead of 1, it's 9.
Instead of 1? Oh,
To
yeah.
get it to be not
Right, right.
1, right?
If there's the number like 9 here, we would have to divide 9 on
Or
both
any number,
sides.
yeah, any number but 1.
We'd have to not, any number with 1, we'd have to divide it on both sides
Would
to
they
create
give us
1.
those kind of problems?
Yeah, just try to explain it because I'm just making it up and I don't want to do a disservice to you guys. Whatever the number is here, you have to divide by it. And then what's going to happen is you're going to end up with what we needed before, with fractions on the bottom. That's basically what will happen, all right? I apologize, it happens. This is 9 and this was 16. In one sentence, I'll sum it up. You need to end up with 1 over here and fractions over here. That's accomplished by dividing both sides by whatever number's over here. All right, that'll come up, so I'm glad that was good. I'm glad you brought that up. Okay. Merci beaucoup. Bye. Yay, math. Yay!